Okay, let's just go over some of the homework that you had for Monday, which is here, page 121. And they're mostly just factoring, finding the exclusions, and simplifying. So I'm not going to go over all of them. I'm simply going to go over the toughest ones. So we're going to look at page 121, number 1. And so you can see that these are like the basic ideas. Then it gets tougher and tougher and tougher and tougher. And the one thing I want you to remember is that fraction rule. So the fraction rule is simply that when you have a fraction divided by a fraction, it is easier to multiply the first fraction by the reciprocal of the second fraction. So as an example, when we have this, and they're just looking for ways to simplify here. If we had this and instead of a division, let's say it's 2/3 divided by 5/8, so just ignore this for now. So if we had actually this question, the best way to go about it is to keep this fraction the same. Take a multiplication sign and flip this fraction around. Doesn't matter what the fraction is. It can be a whole bunch of terms divided by about a whole bunch of terms. You just flip the whole thing around. And that's the best way to go about when you're asked to divide. In this case, I'm just going to look back at why they would give us these first questions. I'm just going to enlarge this a bit. There we go. Why would they give this first question? It's kind of silly, but I think what they want you to get into the practice of doing is before you multiply it out, is to look for simplifications. So right there, 2 can go into 2 1 times, and it can also go into 8 4 times. So that's a simpler way of doing it. You're left with 5/12. Because 5 is the simplest, is a prime number, you cannot reduce your fraction more than this. So I don't know why that's in there. I think it's just for you to get used to the notion of if it works for numbers, it works for rational equations. So here they're just getting you used to the idea of looking at the bottom and the top and eliminating. So when it's a multiplier like this, when they're side by side like that, you can pretty much just ignore the multiplier and put the whole fraction as 1. You can do it like that because it's the same thing now. It's this parentheses times this parentheses times this parentheses. And yes, you could distribute it. Sorry, I accidentally moved it apart there. I'll just move it back. You could distribute it, but why when you can simplify first? But as I've told you before, so this one's already been factored out. As I told you before you simplify, you must find the exclusions. So I'm not going to go through it too slowly because you should know it. So right here, x cannot equal -4. And right here, x cannot equal 5. So those are the two exclusions. You just put them aside and keep them. Okay? And then you can simplify. I'm not going to keep the restrictions. So we're going to look at top and bottom. Because this is multiplying it out here too, we can simplify. You always have to make sure it's multiplied out. For instance, you cannot take this x and simplify it with this x, because they both have a number that's added to it. If they both had the same number, as is the case over there, then they could be simplified. So right there now, I can see that this is simplified by this, so we can just get rid of it. And that's what I'll do instead of replacing it with 1s. And then this right here can be simplified with this right here, so it's gone. And that's what we're left with. The simple answer is x plus 1, you can get rid of the brackets if you want, over 2. Now, looking at this, you'd never know the restrictions, but remember, we found 2 restrictions, so that's why we find the restrictions before getting to this. I'm going to skip the easier ones. Personally, I think this is easy right here. You simply find all the things in the common at the top, so we got 3y's, becomes 2, no, actually becomes 1, just a y, and eliminates this one and this one. See if you can keep up with it. We're left with x squared times an x here, so we got x cubed. And I'll just cross these out so I don't count it twice. This 6 can be divided by 2 and left by 3, and this can be divided by 2 and left by 4. There are no more simplifications left, so up top we're left with 3x cubed, and down at the bottom we're left with 5 times 4, 20 y. And the reason it can't go further is that's a prime number. We can't reduce that unless we can reduce that, which we can't. So right there. I'm not going to skip do these anymore. They're all kind of similar. Like in this one, you're looking at, we can see that there's some x's at the top here that can divide out here. This can be simplified to removing the 3. I might have forgotten some exceptions last one. I can't remember. But anyway, this can become 2x plus 1. And suddenly we see that it matches this here. So these can be simplified. And you're simply left on the top. Here's a 6x times plus 3. So nothing can be done here. But like I said, one of these x's can disappear. And this x can disappear entirely. Until you're left simply with x, 6x plus 3 over 5. Don't forget, beforehand I would have had to find my restrictions. Okay, so again, I'm racing through the simple stuff. If you have questions, just circle and say. So to me, these are all dividing. So they just want you to get used to flipping the second fraction. Okay, so we'll start with the simplest one. Instead of dividing this, I'm going to change the sign to a multiplier, and I'm going to switch these fractions around. And that's all there is to it. So I'm going to take the x squared, and I'm going to put it on the bottom, and I'm going to take the 5 and put it on the top. Boom, done. Now we look for commonalities. We can see there's 1x here and 2x's here. So we just reduce that to a 1. We can see a 3 can't go into the 5 or the 2, so none of the numbers are the same. 2 times 5 here is 10. 3 times x at the bottom, x. And we'll notice the restrictions back here. X cannot be 0. Same with this here, though. So boom, it's done. There's no way you can simplify that anymore. So then they're going to ask you to get more complicated. They wanted you to get used to the flip. So obviously when you see it like this, there's going to be some tricks. There's going to be some tricks. So again, we're going to change the division to a minus. And we're going to flip the fractions upside down. Sorry, the division to a multiplier. Friction upside down. And then we're going to notice that they have some things in common. So we just put this in brackets and we leave the 25 alone. If you wanted to, you could just put it in front of this other bracket, but there's no real need to. You could put it here if you want. Here if you wanted to, but there's no real need to. And instead we're going to say, oh look, there's a 2 in common to both of these, so I'm going to take the 2 out. And I'm left with, let's get rid of that. Since I took the 2 out there, that's gone. And this 14 turns into a 7. So that's what I'm left with. And lo and behold, we see this up here and this up here. Before we start striking it out, let's look at our one restriction. X cannot be equal to, you got it, 7. Because this would become 0. All right. It's a good question as to whether actually that restriction has to exist. I'm going to look into it because it was originally on the top, but yes, I believe it has to. Yes, it does. I'm sorry, it does. Okay, so right away these can cross out. And we can see that we're left with exactly, there's no more x here, we're left with exactly 25 over 20. Because don't forget, we now have to multiply the 2 times the 10. This can be simplified. Both numbers can be divided by 5, which becomes 5 over 4. That's a simple fraction. That's a simple answer. And I believe the restriction is x still cannot be equal to 7. All right. Let's look at the hardest one here. You're going to have to start looking for perfect squares and stuff like that. So here's the hardest one. I'm going to make it a bit bigger. Sorry if I didn't make the last one a bit bigger. Again, I'm going to replace this division sign with a multiplication sign and simply flip the fractions. So this goes in the bottom. This goes up top. And you could even put them all beside each other for visually making it easier. And there's just one big division sign between them. Now you can just do it like that if you want. So now obviously these can't be simplified anymore, so we're going to look elsewhere, and we're going to look over here. We can see that's pretty much simplified as well as it can as well. So let's look over here. Oh, these are all simplified. So we're just going to look for commonalities. Let's find the restrictions. X cannot be equal to -2, x cannot be equal to 7, and x cannot be equal to 6. If you don't know why, let me know. Those are easy. Restrictions you put aside now. And now we cross out this. This crosses out with that. This crosses out with that. And we're simply left with 3x up top and x minus 7 at the bottom with the list of restrictions. Boom. It wasn't that hard, that one, because they already simplified it. And that's when they move on to slightly tougher where they haven't simplified it, right? That's their whole point, is slowly getting you better at stuff like this. So again, we're going to change this to a multiplication. And instead of doing that right now, I'm just going to put this at the top and this at the bottom. And then I'm going to put those in brackets. It helps if you put the original fractions, whatever they were, in brackets. Okay? And now they're just beside each other with a multiplier. So this is a difference of two squares, isn't it? So you get x plus 1 and x minus 1. So let's replace that with x plus 1, x minus 1. X plus 1, x minus 1. If in doubt, expand them yourself and you'll see. This second term has a 6 in common. Has a 6 in common. So we're going to take 6 out of both of them, and we're left with 2 minus x. Let's just keep that x there for simplification. Actually, it'd be nice if I could just get rid of the 6 and this 1. And there, I got 2 minus x. And I've taken the 6 out, so that has to go in front of the bracket. You could even put the 6 way over here in front, just so you can get it out of the way, make it clear. Let's look at the bottom. Nothing to be simplified here, so also let's look at our restrictions right there. Okay? And what do we have at the bottom that we have at the top? That. Oh, no, we don't. Look at that. And you might say, well, they look very similar. Can they be close? Yeah. If I'd taken minus 6 out instead, this would have become a plus x, and this would have become a minus 2. Let's rotate them. Get rid of this. Keep that in mind. When you take out a minus, you change all the signs, and now look at that. Something you didn't see before can be simplified. And that was the trick in this one. We got an x plus 1 up here and x plus 1 down there. Look at that. We've gotten rid of all our denominator. And we're simply left with 6 x minus 1, the simplified form. And if you were to expand that, which you don't, but if you expand it, it would look like that. And you'd never know we came from this. You'd never know you had the restrictions. Now, on the next question, you actually do not expand it. You might say, okay, I'm going to expand it because they've given it in square form. Let's look at this one. Simplify. It says simplify. So up top, it's already been simplified. These are already factors. Down below, we're facing some simple factoring. We got to come up with a number that multiplies to minus 3 but adds up to plus 2. So obviously we're talking about minus 3 plus 1. No, sorry, plus 3 minus 1. So this becomes x plus 3, x minus 1. And this over here, a number that multiplies to 3 and adds up to positive 4 is x plus 3, x plus 1. X plus 3, x plus 1. So boom, that whole thing has been factored. And now we can look at our restrictions. Woo, lots of restrictions. We can see we got 2 of these here, so we're only going to restrict them once. So x can't be negative 3 for both of these. X can't be 1, and x can't be minus 1. Now that we have that, let's look at our simplifying. You put your restrictions on the side. So I have 1x minus 1 at the bottom, and so this 1x minus 1 here just gets rid of the square, just becomes to the 1, or like that. Okay? And then I have 1x plus 1 down here, so the same thing happens up top. This exponent of 2 disappears, becomes an exponent of 1. Then look, I've got x plus 3 times x plus 3, so we can just make it x plus 3 squared at the bottom. And at the top, it's back to the difference of 2 squares. It would be x plus 1 times x minus 1. And there, that's our simplified form. We found the restrictions. Same thing for this one. You got a simple factoring at the bottom. But notice the minus, so you're going to have to flip this fraction and change it to a times. This is a difference of 2 squares here. This is already simplified down there. And this, a 2 can come out. And you're left with 2 brackets x plus 5. So right there, there's a hint that one of the things down here is probably going to be plus 5. No, it won't be. So just ignore that. And that's what you look for. So now we've got 1, 2, 3 done. I have to stop the video because I'm doing another tutoring session. But I will continue it.